So today I want to try to answer the question of what happens if I remove a layer of atoms from my hand, like this. So I take this section of my hands and I just remove the entire layer of atoms that I cross, okay? So this is a really cool question that I found online. It's kind of hard to answer because it's very complicated what's happening in your arm. You have blood vessels, you have bone, you have cells. You could cut across the nucleus, you can remove pieces of your DNA, so a lot of things can happen. So I want to give you a few examples of how you can think about it from a physics perspective, okay? So first of all, it depends on what kind of material you have. If you have like something that is like a salt crystal, which is has like positive and negative ions. So salt is something like that, you know, minus, plus, and then here you have like minus, plus, minus. So you have this kind of thing, and it's like goes all the way in 3 dimensions, this way, that way, and that way, and then you're basically removing this layer. Okay, I'm taking this out, and what you're left with is basically minus, and then on this side also minus, and then plus, and it keeps going, and here you have plus, and it keeps going, and below it you have like plus, and then minus, and it keeps going, and minus here keeps going. So you notice if it's like, if the crystal is arranged like that, then here you're gonna have an electrostatic repulsion between this minus, and that plus, and that plus. But of course you have attraction between this one and that one, and attraction between that one and that one. So one thing that might happen is this one just flies over there, and that one flies to the negative sign that's over here. And so all you're gonna get is this crystal just shifts downwards and sticks to that one. Okay, so let me try to redraw that over here. So we have like plus, minus, and plus, and then we remove the layer here and we end up with the same thing, plus, minus, plus, and it keeps going over here and over here. And then what happens, this one drops there, so you're gonna end up with plus, like, so this one is going to drop downwards. So let me just draw it over here. You're gonna get something like that, plus, minus, and then plus, and then so you're gonna get, these guys are gonna be attracted to each other, and they're gonna be stuck together. So actually we see that what happens here, if you remove a layer of atoms, the atoms just stick together. The atoms just shift by a little bit, and then you won't even notice what happened if the crystal was already arranged in this ordered way like that. Let me just draw it like this. Erase this. You know, if there wasn't like layers, if it was just like a linear thing like that, if it was just a linear thing like this, and I remove this side, now there's plus plus, there's no other thing for it to go to, and these things will fly apart. So it is possible that you remove one atom and the entire thing flies apart because you have plus here. You know, this obviously does attract that, but it will, you know, remember there's more, this keeps going, so it doesn't just flip. So this part does attract that one, but it's weaker because it has a bigger distance. You know, this distance, let's say x1, is bigger than this distance, x2. And because the energy or repulsion strength dies down with distance, this attraction is not enough to cancel this repulsion. Okay? So it could fly apart if it was just linear like that. Another thing that might happen in this setting, maybe we have this kind of molecule, but around there's like some other dissolved ions. So maybe this is all water and you have a bunch of ions here, and then as soon as you cut this up, instead of flying apart, maybe you can get like some negative ion to come and replace it. Okay, so and this process could happen very, very quickly, like 10 to the minus 12 seconds, that you don't even realize it. It gets cut, stuck, and sticks together very quickly that you don't even realize it. Another thing that is maybe more biologically relevant, so here's the arm, and I'm cutting it across, and there's like all these, this is like if I take a cross section here, and these are the cells you know, you might have, this might be the DNA, this is like the chromosomes over here. Let me draw it bigger. So this is like a chromosome, and this is like the arm. So maybe you cut what you've removed is like is something in a gene. It's like an important gene or something. You could remove something like that, and this is what happened in radiation. Like cosmic radiation comes and flies and hits your DNA and changes one base of the DNA for something else, and that's how you get mutations. So you could sort of get mutations in the cells that you cross. Though a lot of those mutations, many of them will be not a big deal. I'm not sure exactly, since I'm not a biologist, I don't know exactly what rate of mutations will lead to danger and what rate of mutation will be okay. It depends on, also physically, it depends on how many cells are you going to cross. So the DNA has a lot of base pairs. A lot of it is not crucial, or only some of it is crucial for encoding genes. A lot of it also is encoding for like metagenes to encode which genes actually get realized and which one don't. So you might miss that process too. But if you're removing just one atom, probably you will not really change things very much. So it depends. This part is complicated. It depends on how many nuclei are you going to cross when you do that, and if you change one gene, is that going to happen? Maybe it could happen that you cross like 100,000 or even more. You change mutations, like there might be small mutations that might not make a big difference, but it could be that by accident you make like a cancerous cell, and that keeps dividing and like kills you eventually. So it could be dangerous in that way. So these are few things that might happen. Another thing, maybe you don't have a crystal, an ionic crystal. Maybe you have like something where the electrons are shared, like in a metal, for example. The electrons are shared, like some of the electrons are free to roam through the entire metal. That's why it's an electric conductor. These electrons are shared, and you have bonds between those. If you cut one layer, all that would happen is, again, there's still attraction between. You cut off this layer, there's still attraction between this layer and that layer, because it's not positive and negative like that, even though it's a little bit farther. They will still attract. One example of this kind of interaction is called Lennard-Jones potential, and that looks like this. So I'll tell you what this means in a second. So this is the potential energy, and this is the distance between two atoms. So this is one atom, this is another, and this is x, this distance. This is the plot of the potential energy, and in order to figure out what that means, just imagine that there's a ball over here that is rolling. What would that ball do? It would just roll down and then go up and down around this point, and then eventually if you put it at this point, it just settles at that point. This is like an equilibrium point. This interaction does the same thing, but if they're far away, if the x is like very big, it's this much, then the ball rolls down over here, so they become closer. If they're too close, the ball rolls out to over here, and it becomes farther. So there's like repulsion on this side and attraction on that side. So here, there is attraction because they're far away. It's kind of a weak attraction, but it's still there. So after some time, which will be probably very quick, these two will gonna stick together again. So most likely, if you remove one layer of atoms in your arm, probably the arm would just still be there, and probably nothing would happen. You might get a few mutations or something like that. Of course, you might say, okay, what if it's a muscle and the muscle is already in tension? You know, you cut it up, and so quickly the thing flies apart because you're pulling the muscle already. Well, that might happen, but remember that, as we said, this rearrangement process where it sticks together again is very, very fast, and it might be much, much faster than the separation that happens from your muscle. So before you do that, it might stick again. So most likely that would be fine, and maybe nothing would happen if you cut a layer of atoms from your arms. Okay, so I hope that was fun for you, and see you next time.